So today we're going to begin our look at linear equations. Now, linear equations shouldn't be anything new to you, but we are going to treat it as if you've never seen them because it is one of the most important topics in all of algebra. So if you can solve a linear equation, then you can expand that knowledge to solve other types of equations. Linear equations are the basis of all algebraic equations. So the first thing we want to do is we want to learn how you recognize that something is an equation. Pretty easy. You know it's an equation because it has an equal symbol. You can call it an equal sign if you want to, but it's really it's one of the mathematical symbols. Signs are positives and negatives, but I know that's been drilled into you that it's an equal sign. It's fine. So, equal symbol, that makes it an equation. What makes it linear is just as easy. There are no exponents or radicals, also known as surds for you guys sometimes. Radicals, roots, okay? So, we know it's an equation because it has a what? There you go. And we know it's linear because you don't have what? Mainly exponents, okay?
What's that thing off the equation?
All right. Just a little arrow, right? Because there are lots of different types of equations out there. So we're specifically working with linear equations. And again, linear equations are the basis for solving all other types. Your whole job, which for solving any other type of equation, is to turn it into a linear equation so that you can then solve it. Okay? So we're going to talk about the process, and we're going to talk about it with the idea of a goal. So there's a goal to solving these. And the goal is to get the variable. Variable just means the letter. Can be any letter, X, Y, A, who cares? Get the variable completely by itself. So we need that variable to be completely by itself. So if you have 2x equals something, then you're not done. If you have negative x equals something, then you're not done. You're not done until it says just plain old x equals something or something equals x. It doesn't matter which side of the equal symbol the x is on, or a, or whatever letter you have, but it has to be on one side completely by itself. And there's a method to accomplish this. And it's always the same. No matter what it is you're trying to get rid of, you're simply going to use the opposite operation. So if you're trying to get rid of addition, what is the opposite of add? Subtract. Opposite of subtract? Add. Good. Opposite of multiply? Divide. Opposite of divide? Multiply. Just that easy. So if you can tell how things are put together, then you know how to take them apart because you've already thought about how they're put together. And so that's the method that you're going to use. Now, of course, in mathematics, you can't just do whatever you want whenever you want. There's always an order. And because we're taking things apart, we're going to use the order of operations, but we're going to use the order of operations backward. We're doing the opposite. We're not putting things together, which is what the order of operations does. We're taking things apart, which means we're going to use the order of operations backward. But before we can even start that, we first have to clean up the equation. And so that's what we'll talk about first. So to start, clean up the equation. We need to get rid of anything that we don't need to have in order to be able to solve it. And the first parts of this are going to look very much like the order of operations, so be careful because it's not order of operations. You're cleaning up an equation. The first thing you're going to do is you're going to clear any brackets. Now, I know that you've worked with brackets before, but I'm going to assume that you have forgotten everything because you may not have learned it well enough, so I want to make sure that you have everything that you need. When you're clearing brackets, there are 3 steps. First, you look inside the bracket and see if there's any mathematics you can do inside. All right? There may be like terms to combine. There may be multiplication or division. It's very rare, but it could happen. The next step is you look for an exponent on the bracket. Now, this doesn't happen very often, but when it does, you tend to miss it. So make sure that you look for the exponent. And last, you look for a coefficient. You may not be used to using that particular math word, but a coefficient is simply a multiplier. So a multiplier, a number that's right in front of the bracket. So for example, you might have 3 times x plus 2 raised to the 3rd power. Clearly that x plus 2 is the inside. The 3 out there is your exponent. And this 3, because it's right up against the bracket, anytime you have something side by side like that with no operation symbol at all, always indicates multiplication. So that 3 is your coefficient, your multiplier. Okay? Now, if you have something between, a plus or a minus between the bracket, then that doesn't mean to multiply. In that case, you still have a multiplier, but your multiplier or your coefficient is actually the sign, the negative. Right? What's a negative in front of a bracket going to do to everything inside? Reverse the signs, change the signs. Right. Good job. All right. Now, after you clear the brackets, the next thing you want to do is you want to clear the fractions. Now, clearing fractions or working with fractions is nobody's favorite thing to do, but if you'll just remember that we can clear the fractions by thinking about the operation. What operation does the fraction bar actually mean to do? Divide. And what is the opposite of divide? Multiply. So all you're going to do is simply multiply every term by the least common denominator, LCD, least common denominator. Now, most of these are only going to have one denominator or one fraction in them, so you don't have to worry about a least common denominator, but we'll cross that bridge when we come to it and talk about how to find the least common denominator. Now, here's your key, though. Every term. The beauty of an equation is you can do anything you want to it as long as you do it equally. So if I multiply one term times 4, for example, that's perfectly fine as long as I multiply every other term by 4, right? And we'll talk about terms to give you a little reminder of what that means in a moment. Third and final step for cleaning it up, after you've gotten rid of all of that stuff, is to combine any like terms that are on the same side. So I mean on one side of the equal symbol or the other, that equal symbol breaks the equation in half, and you're going to combine any like terms that are on the same side. So you're going to look at one side of the equation, combine any like terms, then you'll look at the other side and combine any like terms. So don't move anything at this point. You're just cleaning up the equation, getting it ready to solve. You haven't started to solve. Okay. And we'll look at examples of all of these and how to work on all of those, so don't panic if you don't remember some of them. So once you have the equation cleaned up, now it's ready to actually solve. And we'll solve them by using the opposite operation. But again, what we always have to stay focused in mathematics and do things in the proper order. And since we're taking them apart, we're going to use the order of operations backward. In the order of operations, it's brackets, exponents, multiplication and division, and then addition and subtraction. But we're going to be doing it backwards. So that means addition or subtraction first. There you go. All right. So to solve, first step, get all variable terms on one side. Now remember, all algebraic expressions or equations are made of terms, and it's a variable term if it has a letter in it. So there's really very little thought process here. If it's got a letter in it, it needs to be on one side or the other. It doesn't matter which side. We typically move the smaller. Now that doesn't mean you have to. If you think it'll be easier to move the larger one, it doesn't make any difference. But if you're moving a very large positive number, you're going to do that by subtracting. If you're going to move a very small positive number, you're going to do it by subtracting. And if you subtract a small number, you tend to keep it positive. That's the only reason why we generally move the smaller of the two. Okay? And we're going to do that by either add or subtract, depending on the sign. If it's a positive, you will what? Subtract it. Good. If it's a negative, you will add. All right? So just look at the sign of the term and do the opposite. But whatever you do to one side, you have to do exactly the same thing to the other. So if I add 4 to the right-hand side, that's perfectly fine, as long as I also add 4 to the left-hand side. You can do whatever you want to as long as you do it equally.
What if it's like multiplying by x?
Second step. Get all number terms. On the other side. Remember that this is an equation and it's algebraic. The reason it's algebraic is because it has a letter in it. So those letters tell everything else what to do. So if your variable terms are moving in one direction, say to the left, then all of your numbers have to move to the right. And a number term is just a term that has a number in it, no letters. Okay? So 5, -7. Can't have any letters in it at all. And again, now this time we don't move the smaller one. We don't care. We want the variable or the letter to tell you which side to move it to. But you're still going to add or subtract depending on the sign. If it's a positive, you'll subtract it. If it's a negative, you'll add it. Okay? And the third and last step is to divide by the coefficient. And again, coefficient is just a fancy word for multiplier, but it's the proper algebra phrase. I want you to use the right language. The coefficient of the variable term. Then divide by the coefficient of the variable term. Coefficient is just a word for multiplier, so if it's multiplied, the opposite of multiply is divide. And you can divide by whatever you need to, but if you divide one side by 5, then you have to divide the opposite side by 5. So remember, you have to make sure that you keep it equal or balanced. So whatever you do to one side, you have to do exactly the same thing to the other side. Okay? So hopefully these steps don't look too new to you. They may be expressed in a slightly different way than you've learned them before, but it's a very straightforward process if you'll let it be. If you can tell how two things are put together, then you know instinctively how to move them. Your job is to stay focused and organized, and you've got to learn the steps in order to be able to do that. You have to know when to do what. Okay? So we're going to look at some examples and solve a few equations.